So right now, I don't think I have ever been. I don't think I have ever been as desperate as to understand this topic ever, and that topic will be Green's function. I mean, I can't tell how much important now apparently this looks for me. Like particle physics, if I want to learn you, uh, other than this sheer slamma, which I once told I will talk about it, but I never went because I never understood myself. Uh, this we will keep it aside again for I don't know how many more months, weeks. I hope weeks. After some weeks, I will come back here, and that time I will be capable enough. Now, right now, this thing looks so important. Like for example, to explain scattering and all that. You see this? I don't know these cool words like vertex factors, Feynman diagrams. Seriously, like wow, like I would like to talk about them. I mean, I want to understand Green's function. So, what basically is Green's function? Just a way to understand differential equations, but it's really crazy. So, as far as I know, it's mostly. I think if I understand for second order, it is more than enough. I just don't want to write it. I want to get a good geometrical. Like I just want to visualize it at least. That is the most beautiful part of it. I mean, that will be the most beautiful part of it if it. I just want to do that. So you have some different. Okay, let me open. Keep the Wikipedia ready. Green's function. I want to understand it as good as possible. And if I succeeded in doing that, what more can I ask for? So Green's function will be my target. So let me do it. Uh, and yeah, I gotta close the door. So just a minute. I'm closing it. So here we go. And now uh, let's start Green's function. Uh, uh, so okay, they have some cool stuff here. They talk about this and that, which I don't know myself. Let's so yeah, this is so suppose you have I will only talk up to second order. Anything more than it, it's none of my concern. So you have some second order differential equation. Suppose you have this some function multiplied by the first derivative, some function multiplied by some second derivative. I mean, sorry, this is the second derivative, now first derivative. Then again, some function multiplied by the function, and this is equal to some constant, some other function. And of course, again, I am always free to do this d square y by dx square. I can just differentiate this whole side with a of x, and this will give me some okay some stuff. Okay, so I did some stuff on my function, and there is this differential relationship at every instant of the curve whatever I have. And so basically I will have this some operator which is going to do all this on my function y, and I'm going to get my function f of x. Right, this is what a differential how this is how I write a differential equation in operators. This is how I think a lot of people write, right? I don't know if there is any other way. So if this is the case, if this is the case, what next? What more do we have to solve this? To solve this, if I think it in terms of some linear algebra, or let's say in something like linear algebra, if I find the inverse operator of this, I am done. It will be something like this. In layman language, I don't want to argue with any mathematician. Man, they suck really. Okay, not to offend any mathematicians, but recently a few of them I have talked, they just don't get off your back. Okay, they are like they just die on the definitions. You just keep feeding them the definitions and proofs. That's all they care about. No physical interpretation. It's like talking to a dead man or something. But yeah, of course, they are mathematicians, and doesn't matter whatever they are talking, they will be damn right. And I feel like a chimpanzee in front of them. That is a different issue. So now let's uh, uh, so let's see what I can do. Some math. So Green's function, right? I try to find some function g of x comma s such that when I apply this operator on this g of x comma s, I get some delta of x minus s, right? So I'm like, okay, I forgot whatever this function is. I will find some function g of x. That will be the problem. That is another issue in itself. What will it be? That we will think later. But if I find this, then I should get delta x minus s. So for example, suppose I have something like this: d square y by dx square plus uh, let's say 3 dy by dx. I am keeping everything as simple as possible. What more can be simpler than this? This equals to some x square. I want to solve this, and we know that this is the general solution will be some constant 1 times the first complementary function plus c2 times some other complementary function. These constants are very important, only then shit makes sense for me. So please keep them, never ignore them. Plus finally your particular integral function. The reason why I am telling this is very important, as far as I have seen, they bugged my head like anything. The reason is, suppose you have a 0 this side, right? So then if the 0 is this side, this won't be there, and only this will be the possible solution for all c1 and c2. But the problem is, when you input, like when right on the right hand side there is x square, when you apply this, when you put this in the function, you will get x square, right? When you put this in this equation on here, you will get x square. But doesn't matter what you put here, this when you put this in the differential equation, you will always get 0, as if this doesn't even exist there at all. And that is like kind of, how should I say, I don't know what to say. Uh, what is the job? What is the job? If I have x square, this thing, right? So this is some operator y. I got x square. So the minimum necessity is, if I put some function here, I have to get an x square here, right? So I will definitely get that. I have to put this. This is like a necessity. If you, even if you say screw this function, I don't want, you have to put this function particular. You must put it so that you at least get an x square on the right hand side. Then it's just a matter of your convenience. You use whatever constant you have, c1 c2. You can just put them 0, or you can whatever, depending on the situation. These are like extra things which come free with this when there is a x square in the right hand side. So that's how I think about it. I don't need to be some math guy for epsilon. Oh my god, those people are on my nerve for some reason, since I have argued with them. And I guess I shouldn't have argued with them, because whatever they say feels just so damn right, man. Like seriously, it feels so damn right. I don't see any physics in that, but they know their game. I don't. So yep. Or do they know? They make their own game, right? I don't make the game in physics. Physics is physics. Okay, fine. Let's continue. Uh, uh, so now, um, oh, so yeah. So I will. So for now, suppose I say, okay, I don't care whatever on the right hand side is. Let me analyze only on the homogeneous part, and then I find a particular function, g of x comma s. This is a parameter. I can vary it up and down. It doesn't matter. When I put this in my when I apply this operator on this function, I should get delta of x minus s. What does this really mean? I don't know. So the thing is, how should I say? Uh, if here there should be a 0, this is only possible when I put the homogeneous solutions, right? And mathematically, it has been proved that any second order differential equation will have at most two uh, two linearly independent solutions. So, and okay, I don't even need to talk about two now. Like if you have some nth order ordinary differential equation, you will have three linearly independent solutions. I'm not gonna prove it. Oh my god, these mathematicians are in my head now. I have to get rid of them. Damn, I am getting some kind of disease to prove everything, which probably won't even help me in. It will help, but not to such extent that I will find some extraordinary physics theory. No, no, no thanks. No thanks for that. Even if I did, I won't pay. I don't want that. No, sorry. It's like somebody gave me a screwdriver to fix the TV, and I am now I'm just mesmerized by the screwdriver. I'm just wasting my whole life understanding the screwdriver rather than fixing the freaking TV. So now, uh, so now, yeah. So what should I say? I put some function here which will definitely be my uh, Green's function, which will be so I think Green's function will be just some combination of my linearly independent solutions. Only then it will make sense, right? So let me see what happens. Okay, now this feels interesting. Suppose that I have this, okay, dy by dx. Okay, let's just write this. Dy by dx is equal to 0. So what are the solutions? The solutions are okay, this is just a constant, right? The answer for this will be just some constancy. So can I write something? So can I like find some such that this will be uh, such that this will give me this, and of course I can. This will be, I think, so I can write something like this, right? Uh, so it will be something like this. Uh, you can just it will be just step increase. So basically, how I can define is I can have some. So this is, let's say my function is only defined between these two parameters, and I will have some uh, and at some s I will have a step increase. So s. So this is like a slider. S is like a slider. I can keep changing here and here. If my s was suppose here, then I will have a step here, and this will be something like this. But now I kept my s here, so it's like this. So now, uh, if this is the case, if I use this, so basically, if I say that g of x comma s is uh, 0, I mean, let's say some constant when c is greater than, I mean, when my x is lesser than this parameter s, and some other constant when x is greater than my parameter s. And you can see, like, for step functions, I think, as far as I know, you must be knowing that you will get delta functions, right? So let me see, like, for example, you have, let us say, uh, y of x is 0 when x is lesser than 0, and 1 if x is greater than 0. So what would happen when you try to take the derivative? So this will be uh, something like that's weird, right? It will be like 1 minus 0 divided by uh, epsilon, as epsilon goes to 0. Oh shit, and this just gives you a spike, and I will define this as my delta function. Again, oh my god, this mathematician, why are they in my head? Please get out of my head. So now, uh, if I do that, uh, so yeah, I don't know what can more be rigorous, and and you can clearly see, right? So if I integrate this, let's say from 0 to x, from some reference point to x, right? Y of x dx. I mean, integrate this derivative dy by dx times dx. So you can see this actually kind of works, right? So you will have to only care about that small epsilon at the origin, and you got epsilon times 1 by epsilon, and this gives you 1. So okay, so I will define my delta function like this. So while you are going, if you just increase one step, my delta function, this will be my delta function. So if you, let's say you increase 2 steps, then my derivative by 2 will be 2 times delta function, and so on. Damn, I want to discuss some a little with a mathematician. So wait for a while. I want to talk a little with a friend. Mathematicians, I hate you guys, but I need you. So I finally completed the discussion with my math friend, and everything feels all right. So I can continue. Uh, I was just talking a little about variations and differentials and stuff like that. So I think I'm more clear now. We can continue. Everything is good. The definitions we use feel very plausible and consistent. Yeah, this thing makes kind of sense. So I am good with it. I am happy with it. So now, yeah. So if I have this, what should I say? If I have this condition, suppose some constant is there, and that constant plus an extra addition, can I use this to construct my whole solution of the other function? So what I mean is, so if this is x square, if I multiply g of x on both sides, and what more should I do? I think I can just write this as d by dx of y times g of x s minus y times dg by dx is equal to x square g of x comma s. So if I do that, uh, so if I do this, then finally I can do more. What am I saying? uh, so here this thing will be 0, doesn't matter what I do when I integrate on both sides. But here I might get something interesting. uh, what would I get here though? So then what more can I do? Yeah, here I won't get anything if I integrate on both sides, like if I integrate both sides with some reference up to some x, and so finally I will get y dg by dx integration uh, um, is equal to, let me do it properly, dy by dx g is equal to g times x square, and if I integrate both sides, uh, I don't know what will be the limits, but let me see what I can do, is equal to g times x, right, dx. And now uh, this can be written as g times y, some integration uh, g times y, because I'm just using the chain rule. You can just see yourself whatever I'm doing wrong if you think so. And then I have uh, dg by dx times y dx. This will be equal to integral gx dx. And by the way, I just use integral u v dx is u times integral v dx minus integration of du dx integration of v dx. So where my v is just dy by dx, so I have to integrate this. So that's why I got this y, blah 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 blah. And so this will be equal to g times y integration, and you know what will this be, right? So this will be delta of x minus s y dx is equal to gx dx, and so my y will be equal to delta of gx dx plus delta x minus s divided by G. Wow, what kind of hell is this? Okay, that's all for today. I am done. Bye bye. I did something. I don't know what it is, but see you.